In this session, we'd like to introduce Goldstone open source NOS for optical packet transponder. I'm Wataru Ishida from NTT Electronics America, and also Kingston from PAUC are going to make this presentation. So first, Goldstone, it is an open source network OS for optical packet transponder. Optical packet transponder is it looks like a white box, normal white box switch, but it has a coherent transceiver for long haul transmission. And we have in the market we have H-core Cassini or Wistron Galileo for this kind of hardware. So the Goldstone is the OS for this kind of hardware. It is developed under TIP, Telecom Infra Project, OPT community. And it's already running in a production network, and the source code will be available in the following link. So we started this OS, this development in the TIP community, but we didn't start it from scratch. We leveraged many OCP technologies. So today we'd like to show how we combined every pieces and put it to one full-fledged NOS. So before diving into the Goldstone, first I'd like to highlight what is happening in open networking. So the server operation is influencing all the IT infrastructure fields. So starting from the data center network, many hyperscalers are utilizing how to operate, the way to operate a server to the data center network gears. And OCP has been contributed. OCP community has been contributed. Made a huge contribution to this field. So, for example, ONI, Open Network Linux, and of course Sonic is developed in this community. And then the application of these software is expanding to the wide area network as well. So some folks are working on supporting the Ethernet chip optimized for the wide area network in Sonic and SAI. And finally, the trend didn't stop at a wide area network, but finally it's also expanding to the optical transport network. This slide talks about the OS model, how the consumer, the operators are consuming the OS of the server and network gears. So as for the server, everyone install the base OS like Debian, Ubuntu, then install application what they need. But by contrast, for the network gears, at this time, many operators need full-fledged and turnkey NOS image. And the Sonic is taking the same method at this time. So when you build Sonic's ONI image, and when you install it on the white box switch, you get everything what Sonic is offering. But in Goldstone, we think maybe we can apply the server OS model to network OS as well. Then we started a project called Microsonic. So Microsonic's final goal is realize apt-get install Sonic. So it is a minimalistic Sonic package, or we could say a distro, which can be installed on any Linux distribution. So at this time, this is a really early stage. It's still a POC code, but The goal is make the SWSS and the SAI in a single binary, the similar model as a BusyBox. So we can execute Oak agent or any SWSS daemon with the single binary. And also Microsonic intentionally exclude any CLI and management layer. So the requirement for the management layer varies among operators. So I think one thing can't fit to the all operators. So in the Microsonic project, we intentionally exclude it. So the user will use whatever they need, but it uses Redis as the Sonic is using it. So the user can interact with the Redis database to do any configuration or monitoring. And also it tried to enable the easy build time, runtime customization. So by default, when you boot up the Microsonic, it will use the virtual switch libsai by default. But at the runtime, of course, you want to use the libsai provided by the real Ethernet ASIC vendors. So you can switch to that without changing the actual binary. And the source code is uploaded in the following link. So this is Microsonic. And then to support the optical packet transponder, we also need to think about how to control the transport layer. So the disaggregation, as I said in the previous slide, the disaggregation, the open networking is also finally happening in the optical network. And we have white box packet transponder from several ODMs. But since these hardware have the coherent transponder, coherent transceivers, we need to make some kind of abstraction layer to control these new hardware in a vendor agnostic manner. So there was a demand for open software abstraction for optical transceivers. So we made TAI. So as you can imagine, TAI is derived from SAI. So TAI stands for Transponder Abstraction Interface, whereas SAI stands for Switch Abstraction Interface. So the many things are similar, but TAI is for controlling the coherent optical transceiver. And actually, I made a presentation in the last OCP summit. So if you're interested, please see the following link. Okay, and next topic is how we made a management framework in Goldstone. I think I can switch this to Kingston. So Kingston, please.
Yeah, thanks, Wataru. Actually, before getting into this slide, I just wanted to introduce myself. My name is Kingston, and I am from a startup company called Palsy Networks. So coming back to the Goldstone management framework side, as you may know, the management layer is one of the key component of any network operating system, and so for the Goldstone management framework, we are planning to support the different network operations via CLI, SNMP, NetConf, PressConf, and GNMA as of now. And we are hearing a lot of interest from different operators about the Yang model and the unified management layer, because that is you may need to have a common management layer for configuring your box, as well as to get all the information, status, etc. So what we have done was we have chosen Sysrepo as the common management layer infrastructure. So all the different protocols, the northbound protocols, will be interfacing with a common management layer via sysrepo, and sysrepo provides a single interfaces towards the different northbound APIs. Okay, so probably we'll discuss about this in detail in forthcoming slides. Next slide, please, Taro. Yeah. So this is the high level architecture of Goldstone. So I'm just planning to explain from down to bottom. So as you may see, you are seeing the 4 different layers in this architecture. One is basically the base operating system layer, which we have chosen the ONL. And the second one is basically the orchestration layer of the different containers and the components running inside the NOS. And Kubernetes is basically will be used as an orchestration layer. And then you have the control layer, the third layer, which is the control layer. So in the control layer, you might be seeing multiple different verticals, starting from the platform controller to the Ethernet ASIC controller and the optical transceiver controller. Followed by that, you might be seeing some the protocol level details like L3 routing, PTP, and etc. So the core control logic as well as the programming, the platform lies in this particular control layer. And for platform controller, we are using ONLP for doing for acting as a platform controller. So this helps in basically getting the different status of the different peripherals attached in the white box, like your fan, LED, and things like that. And followed by that, the Ethernet ASIC controller is the one which controls the Ethernet ASIC side, right? So as you may know, basically, for example, any OOPT based hardware, if you see like a Cine, there are 2 different basically aspects. One is basically the Ethernet ports, and another one is an optical ports. And here the Ethernet ports are programming the Ethernet ports, and traffic forwarding from the Ethernet ports or towards the Ethernet ports are handled by the Ethernet ASIC controller. And the optical ports basically is controlled by the optical transceiver controller. Okay. So inside the Ethernet ASIC controller, as Wataru has mentioned, we have taken Microsonic, which is basically a toned down version of the Sonic. And for optical transceiver controller, we are using the TIE, which is basically the transponder abstraction interface for programming the coherent side of the equation. So, okay. And followed by that, we have the unified management layer, wherein you might be seeing sysrepo, followed by that multiple northbound APIs or northbound protocol support. Okay, CLI, Netcon, RESTCon, GNMA, and SNMP. So we are adding this particular the management layer support as of now, and most of the work towards the control layers as well as the base operating system is already done. And right now we are working more towards adding a management layer infrastructure into place. And if you see, really, we have added the management framework infrastructure, at least with CLI and Netcon, for both controlling the platform controller as well as the optical controller. And for the Ethernet ASIC controller, the work is in progress. Next slide, please. Yeah. So this is the little bit detailed version of the architecture. And if you see, the sysrepo POSIX is basically the common management layer, and which has the different YANG models will be registered inside this sysrepo. And there are multiple northbound protocols which will be interfacing towards a sysrepo. And we have a southbound APIs or southbound layer, each one for a different control APIs. Okay, so if you see, there is a southbound controller for controller API towards the libONLP, which is nothing but your platform controller. And there is a sysrepo South Sonic, which is for Sonic. And there is a southbound APIs towards the TIE layer also. Okay, So from the Sonic perspective, what we have done was, as of now, we have taken the Sonic management framework as the interface to communicate or interface the different Sonic components running inside the Sonic layer. So the Translib is one of the key components which is provided by the Sonic management framework. And we have basically integrated, or we integrate the Translib APIs into the sysrepo southbound Sonic, just to make sure that we are using the complete the Sonic management framework also to program the Sonic related information. So, okay. So if you see, most of the works what we have done is so far is on the platform side, the controller sides, as well as from the management side. So right now we are more concentrating towards integrating the management infrastructure into the complete Goldstone project. Okay. Next slide, please. Yeah. So we welcome the pull request and feature requests from different operators and new hardware support requests from different vendors. And so we request any proposal in terms of field trials, in terms of test, and in terms of new deployments. We always welcome. And we would like to have a direct communication between the operators and the developers, in order to make sure that basically the development cycle is faster and more efficient. So please drop us any requests in terms of new features, or in terms of new trial support or anything. We are always here to basically help in terms of adding new features, as well as supporting any trials. That's it from my side. If you have any question or any queries, probably, yeah, we can take the questions, and we can provide the answers. So, thanks, guys.